Welcome to SFRCM Learning. In this e-content video, I have discussed about bilinear transformation by exploring properties and fixed points. I am Mrs.N.Akila, Assistant Professor, PG and Research Department of Mathematics, the Standard Fireworks Rajarathinam College for Women, Sivagasi. For this introduction, I have presented the bilinear transformation, which is called Mobius transformation, including their properties, fixed points and with specific cases. In the table of content, I have listed definition of bilinear transformation, properties of bilinear transformation, which includes mapping characteristics, fixed points of bilinear transformation, specific cases of fixed points and invariance property under cross ratio. The first one is I have discussed about definition of bilinear transformation. A transformation which is of the form W equal to f of z, that's equal to az plus b divided by cz plus d, where a, b, c, d are complex constants with the determinant of 2 by 2 matrix a, b, c, d, it's not equal to 0, is called bilinear transformation. For this, let us consider the example f of z equal to z minus I divided by z plus I, with a equal to 1, b is equal to minus I and c is equal to 1 and d is equal to I. The determinant of this is called calculated by 1 into I minus of 1 into minus I, which is equal to 2I, and that value is not equal to 0. Therefore, this transformation f of z equal to z minus I divided by z plus I is called a bilinear transformation. The next we have discussed about properties of bilinear transformation. The first one is the inverse of any bilinear transformation is also a bilinear transformation. And next one is no two distinct points in the z plane map to the same points in the w plane. That is, the bilinear transformation is a conformal mapping for all finite points in z plane except the point z equal to minus d by c. For that points only, the denominator becomes 0. Therefore, it is a conformal mapping for all points except this one. The next one is the set of all bilinear transformation is a group under composition. That is, it is this collection of bilinear transformation holds 4 properties. The first one is association property, and second one is identity property, and third one is inverse property, and it is also satisfies the closure property, but it is not a abelian group. That is, commutative property is not hold for this. The next one is mapping characteristic. Every bilinear transformation maps circles and lines into a circles and lines. That is, a line can be viewed as a circle of infinite radius. The next one is we have discussed about fixed points of bilinear transformation. A fixed point of bilinear transformation is a point in z plane that remains unchanged under transformation. Mathematically, it satisfies w equal to az plus b divided by cz plus d, that's equal to z. These are calculated by solving the quadratic equation cz square plus d minus a of z minus b equal to 0. Then we have used the formula z equal to minus d minus a plus or minus root of d minus a the whole square plus 4bc divided by 2a. Next, we consider the example f of z equal to z minus 5 divided by 2z plus 3. For this transformation, we find out fixed points by putting f of z equal to z, that is we get 2z square plus 2z plus 5 equal to 0. By solving this quadratic equation, we have two fixed points. The first one is minus 1 plus 3i and second one is minus 1 minus 3i. Next we discuss about some particular cases for fixed points. For the bilinear transformation, f of z equal to az plus b divided by cz plus d. If b is equal to 0, the fixed points are z equal to 0 and z equal to a minus d divided by c. If c is equal to 0, the fixed points are z equal to infinity and z equal to b by d minus a. For the special case d minus a the whole square plus 4bc equal to 0, the fixed points are a minus d divided by 2c. For the next case, the transformation, if it is a translation, that is w equal to z plus b, the fixed point is z equal to infinity. For the magnification, w equal to az, the fixed points are z equal to 0 and z equal to infinity. For the inversion transformation, w equal to 1 by z, the fixed points are z equal to 1 and z equal to minus 1. The next one is the bilinear transformation is invariant under cross ratio. For that, suppose z1, z2, z3 and z4 or 4 points in the z plane are mapped to the 4 points in the w plane, that is w1, w2, w3, w4. Then the cross ratio is defined as z1 minus z3 into z2 minus z4 divided by z1 minus z4 into z2 minus z3. That's equal to w1 minus w3 into w2 minus w4 divided by w1 minus w4 into w2 minus w3. The bilinear transformation that maps z equal to 2i minus 2 in the z plane to the points w is equal to 1i minus 1 in the w plane can be founded by the method of cross ratio, that is 2 plus 2 into I minus z divided by 2 minus 2 into I plus 2. That's equal to 1 plus 1 into I minus w divided by 1 minus w into I plus 1. Therefore, the required transformation is w equal to 3z minus 2 divided by 4 plus I into 4 minus 2z by 8. Therefore, under the cross ratio, the bilinear transformation is invariant. Next, we conclude the presentation, that is bilinear transformation or key concepts in complex analysis due to their unique properties and versatile applications in mapping points between different planes. Thank you for everyone for your patient learning. Thank you.